Okay, so we've been looking at differentiation, and we were looking at tangents and normals. So our next part of differentiation we have to look at are turning points. Okay, so it's just an extension of what we've been doing. So if we look at some of the graphs that we've been looking at, what we've been doing is we've been finding the gradient of tangents at different points on these curves and finding the equations to them. Okay, so if we just look at, first of all, quadratic curves or quadratic graphs. They take this basic shape. Our lowest point and our highest point are really useful and really important within looking at quadratics. And if we look at the tangents at those points, you can see that they're both going to be horizontal lines. So the gradient of the tangent at both of these points is 0. These are called turning points. So this is where your graph turns round. So this is a minimum turning point, and this is a maximum turning point, and the gradient of the tangent is 0 at both. Okay, now there's an extra wee thing to know about here is our second differential. So we did this back in chapter 6, but now when it comes to turning points, if d2y by dx squared is greater than 0, we have a minimum turning point. And if d2y by dx squared is less than 0, we have a maximum turning point. So they're kind of the opposite that you think. If it's greater than 0, it's a minimum. Less than 0, it's a maximum. And you need to know these two. Okay? So let's look at our examples then. So example 1, and we're just going to look at quadratic graphs at the minute, and then we'll move on to cubics. So for each of these examples, the question will be, find the turning point and state its nature. Now the nature of the turning point is just the, is it a maximum or is it a minimum? So our first equation, y equals 2x squared minus 7x plus 3. So if it's a turning point, we think, right, we'll need to find dy by dx. So differentiate, and we get 4x minus 7. For turning points, dy by dx equals 0. So 0 equals 4x minus 7. 7 equals 4x. So x is 7 over 4. So we need now to put that back in to find y. And it turns out to be minus 25 over 8. So that's our point. Okay, so that's find the turning point. That's our turning point. Now we'll have to state the nature. So we found that dy by dx was 4x minus 7. Let's now find d2y by dx squared by differentiating again, and we get 4. That's obviously greater than 0. Therefore, it's a minimum turning point. So our answer, our coordinate, 7 over 4 minus 25 over 8, and that's a minimum turning point. Also, just think about the shape of the graph. That's a positive x squared, so it's a positive quadratic, so you know it's that sort of shape. It's a smiley face, so you would expect to get a minimum. Okay, our second one then, y equals 7 minus 8x minus x squared. And again, the question's still the same. Find the turning point and state the nature. So we get dy by dx, and we get minus 8 minus 2x. For turning points, dy by dx equals 0, so minus 8 minus 2x would have to be 0. So that's minus 8 equals 2x, and x is minus 4. So that's our x coordinate at the turning point. Put it back into the equation of our graph. And find the y coordinate, and it turns out to be 23. Then we want to find the nature. So we'll have to find the second differential, d2y by dx squared. So differentiate this again, we get minus 2. That's less than 0. So therefore it's a maximum turning point. So our answer, the coordinates of our turning point are minus 4, 23, and it's a maximum turning point. Okay, so again, look at your graph. It's a negative cubic, or quadratic, so you know it's this sort of shape. Okay, so you would expect to get a maximum turning point. Okay, and our third one, and the question, remember, is still the same. Find the turning point and state the nature. So y equals x plus 4 upon 2x minus 1. So the first thing we need to do is multiply out our brackets using FOIL. So we'll get 2x squared minus x plus 8x minus 4. Tidy that up. And we get 2x squared plus 7x minus 4. So again, dy by dx, that's 4x plus 7. For turning points, dy by dx has to be 0. So 4x plus 7 is 0. 4x would be minus 7, and x would be minus 7 over 4. Put it back into the equations to find y. You can either put it into the one with brackets, or you can put it into the one that you've multiplied out. It doesn't matter. Okay, so putting it into the equation, we find out that our y coordinate is minus 81 over 8. Then we want to find the nature. So again, we have to differentiate, get the second differential. So differentiate our dy by dx, and we get 4. It's greater than 0. Therefore, it's a minimum turning point. So our answer, our coordinates are minus 7 over 4, minus 81 over 8. And it's a minimum turning point. And again, just looking at our equation of our quadratic, it's a positive quadratic, so you know it's your smiley face shape, so you would expect to get a minimum turning point.